Hello everyone, welcome back to a GIS mathematics lecture video. And in this lecture video I want to continue our discussion on sort of the basics of matrix algebra by talking about this idea of scalar multiplication. Right, scalar multiplication. And I want to approach this in the same way that we did matrix addition and matrix subtraction, by first talking through conceptually what happens using letters to symbolize numbers, so that way we can see sort of a generic case. And then in the next video, go through some concrete specific examples. So let's talk about scalar multiplication and what we're actually trying to do here. So specifically, scalar multiplication deals with multiplying a matrix by a scalar. See if I can make that look a little bit cleaner. By a scalar. Right, if you remember back to our definitions, right, a scalar is just a number. Right, and one of the reasons why I said scalars get their name from scalar multiplication, because they make a matrix bigger or smaller. Now we're going to see sort of what that meant. So let's just go out on a limb here and assume that we have some scalar that we're going to call C. Well, actually, let's do something so you know it's a lowercase, because uppercase and lowercase c's look very similar. How about we do a scalar we'll call E? So this is our scalar. Right, and let's go ahead and multiply our scalar by a matrix that we'll call A. Right, this is our matrix. Okay, so this is what scalar multiplication is going to look like sort of arithmetically. The lowercase letter designating a scalar, uppercase letter designating a matrix. Okay, so let's go ahead and define a matrix. Let's go ahead and define our A. I'm going to do A equals, let's do a 4x4 case. We'll have A, B, C, D. Right? This is a 2x2, right? A 2x2 matrix, 2 rows, 2 columns. And we're going to multiply A by this scalar we called E. Okay. So what is it going to look like now to have E times A? Well, just like with addition and subtraction, right, we're not going to change the dimensions. Right, so our dimensions are going to come out, A times E is still going to be a 2x2 matrix. Okay, so what I want to do is I want to color code the A variables red. So we're going to bring our variables here, A, C, B, and D, right? Just like matrix addition and subtraction, right, we're bringing our elements from A. Because we're multiplying, I'm going to use the dot here to show that we're multiplying. And then we're going to bring our scalar, which is going to be the same for each one. Right? We're going to do E, 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 and E. Right? So if we sort of simplify that down a little bit, maybe hopefully you consider this, hopefully you think this is simpler. I don't know for sure. Right? We're going to get AE, right? I've removed the dot to show that we've done the multiplication. Right? BE, again, we've done the multiplication. CE, again, we've done the multiplication. And DE, because we've done the multiplication. Right? So in this case, right, multiplying a matrix by a scalar, you just multiply each element in the matrix by that scalar. That's how scalar multiplication works. Scalar division works the same way. You just divide each number by the scalar. Okay. So just to sort of pay attention to what happened here, right? Again, we do not change the dimensions. Right? 2x2 input matrix. 2x2 output matrix. The scalar does not affect the dimensions of the matrix, right? You're multiplying each element by the scalar. So we do not change the dimensions of the matrix. Okay? I just want to scroll back up and just quickly recap again. Multiplying matrix A by scalar E, we multiply each element in A by the scalar. So if A is A, B, C, D, we multiply A times E, B times E, C times E, and D times E. So we get AE, BE, CE, and DE. Again, for multiplying a matrix by a scalar. Hopefully that makes sense, and if you have any questions, please reach out. Thank you.